talk about code, electrical power and lighting system. So section C405 of IECC 2018. This is part one. So we're going to go over lighting power allowance and lighting power demand that you're allowed to have over the section. Part two is going to go over control strategies and how to implement those, software, hardware requirements, etc. So this my screen so I can see. There we go. Seeing that it's duplicated, not extended. Okay, so these are the specific sections we're going to talk about. Sections I'm not going to go over is 405.6 to 405.9. That's not applicable to lighting. That has to do with escalators and motors and elevator drivers and things like that. So where do you start? Typically, so here's kind of the workflow I would suggest. Are you interior or exterior? Typically, you're starting with interior. So typically, we're the examples I'm going to show, we're going to start there. Next, you need to determine your building type. Is it a shell or core? Is it speculative? As in, hey, we don't really know what it is yet. It's going to be built as suite for tenant lease out. Or is it known? And note that if it's a dwelling unit, aka multifamily, you're going to have to comply with R404-1. Okay. Next, floor area or building area. So the total area or the estimated total area of the building. And then space or room schedule. How is the building going to be used? Estimate space type. So to your best guess right now. So for the example, interior, I'm gonna show you high school. It's roughly 160,000 square feet. And then, we're going to go with a typical standard programming for it. So classrooms, gymnasium, administration. So lighting allowance or lighting budget. So in the code, they called it allowance. Really, we're determining our budget, and then we're going to determine how to allocate that budget. Okay, but code calls it allowance right off the bat. But in my opinion, it's a budget. So for all intents and purposes, area shall be defined as contiguous spaces. So that means sharing a border, right? So, Colorado versus Idaho, we're not contiguous because we don't share a border, but other spaces would. That's important for like transition spaces, or classrooms are sharing a transition space. That would be classified different under space by space. But we're talking about the building area method. So this is how we're going to do it. So we have 160,000 square feet. We determine our program type, lighting power density, total area divided by watts. Total watts is basically being substituted with interior lighting power. Sorry, so we're just flipping the variables around here. So LPD equals area over watts. Instead, we're going to get watts equals area times LPD for interior lighting power. So for our example, refer to table C405.3.21. It's just a table. It's readily available. You can find it online as well as in the code book. You just look up. So for us, school/university. So we have a limit of 0.81 for our LPD. So we take our area times our lighting power density. That tells us we have 129,600 watts to spend. Now the space by space method is a little bit different. It's determined by multiplying the floor area of each space times the value of the space in a separate table. It's much more extensive, and it's classified into two types. You've got typical space and then specific space types. The specific space type overrules the common space type, always. But so if you don't know your building program, we want to estimate it. It's pretty, depending on the building type, there should be you should be able to fill out the majority of the building program. So here's kind of in my fictitious high school that I'm designing the program, right? Now this kind of works for the building area method, because we kind of can estimate the whole building size based off these programs, but not for the space by space method. Once you get a little more specific. So for classrooms, English, math, history, specialty would be music, science, theater, art, or special needs. Hallways, I bring that one out because it's a high school, so we're concerned about the width of the hallways. They're much larger than normal. So depending on how we do that, that could change our lighting plan slightly. Administration, offices, conference rooms, nurse, IT. So really break it down like what goes into a school program. And if you're struggling to come up with that, find a school relatively your size and look at the programming of that school. And just you kind of use that as your reference point. Because again, we're just estimating here, okay? So, and then you basically refer to the table, common space types, and you basically look it up. Audience seating area in a gymnasium is different than the actual playing area for the gymnasium or the fitness area. Here I pulled out laboratory in or as a classroom because we have chemistry in our high school, and they have butane burners. I'm going to deal with chemicals, so it's a laboratory setting. You could probably make an argument for the physics or biology, depending on if there's any experiments. If they're dissecting a frog or something, then biology probably could get categorized as that. Locker room, dining area, in cafeteria or fast room dining, so it's cafeteria for us. Basically, you just kind of go through here, go through the table, and just make your own separate table of this is applicable to my project right now. And so you kind of go through that, find all the ones that are appropriate. Notice because this high school is big enough, and it has a seating area for viewing, so it's going to have home games, away games, etc. So we have sports arena, playing area, class 3 facility. So there's different levels of class for the playing facility depending on the size of it. Okay, so for us, for our size of high school, it's class 3. For bigger ones, it'd be class 2, and really, really big ones are class 1. So, and library, notice, is broken down into 2 areas, the reading area and the stacks. So call that out, even if the stacks are broken up and surrounding the area, the reading area. And as I mentioned, they're separated in the common versus specific. Specific, that's gonna be the point, sorry. Emails I'm getting, sorry. The specific space type shall always overrule the common one. So here's what I like to do, either in Revit or Excel. Just make a table, lay it all out, have Excel do the math for you across the board, figure out the area, and then that's your ILP or watts allowed per space type. So the building area method versus space by space, how do you really decide? Building area method is a quick and easy, however, no exceptions can be applied or are allowed. So what you get is all you get, nothing more, okay? And you also don't get rewarded for spending less than what you're allowed, okay? So really, shell and core or speculative building is what I would recommend, or using it as an early design or conceptual phase where it's like, hey, this is the ballpark estimate of what we're allowed to spend, because it can be pretty close. Space by space is more granular, and it ensures sufficient allowance is available to meet space requirements, because it's on a space by space or a case by case basis. Exceptions can be applied as well as trade-offs. So once you know your program, or you're kind of in the schematic design, or you're moving out of schematic design into construction documentation, apply this. And the reason why I say start early and estimate and fill it out as you go in the design process is this work has to be done. So do you want to do it all at once, or do you want to do it piecemeal over time? And piecemeal over time kind of helps you keep track of things, in my opinion. So again, building area method, standard predictable program. So office, shopping centers. When I say shopping centers, I don't mean retail. I mean big box stores. So that you would, have a random assortment of tenants, Office Depot or Spirit Halloween or whatnot like that in. Space by space method, specific building types, or if you have specific space types in the building in mind. So museum, theaters, casinos. I put these 3 up there because they have the most exemptions in the code for lighting. They get away with highway robbery, in my opinion. So in my opinion, it's really just the dealer's choice. You have to make a judgment call what's best for your project. So for the building area method, for our example of the high school, we have 129,600 watts as our allowance, but that's all we get, versus the 132,808.5 watts that were allocated on a space by space basis, and we're allowed to trade off in certain space types we can apply for exemptions. So variables to consider is square footage. That's the biggest one. The bigger you are, the more productive the building area method is going to be, because the margin of error is acceptable. For smaller ones, you definitely want the space by space method to ensure you have proper allowance of wattage. So program requirements is another one. So even if it's a small or large building, but it's a museum or a movie theater or casino, space by space method. So information drip, when is information going to become available to you? When are you deciding the program, the size of your classrooms, the overall square footage of your programming that can be allocated, things like that. So some examples would be retail, department store. You start with a building area method, but then as the program becomes defined, you find out you can benefit from the space by space method, i.e. if you're selling clothing and jewelry versus sporting goods, there's special exemptions in that. I'll go over that in a little bit. Grocery store, food only would be building area method. But then if you have food and retail, so you're selling other goods in addition to the food, then you're benefiting for exemptions if you apply the space by space method. Schools, elementary or middle would, in my opinion, benefit from the building area method. They're very straightforward, simple, standardized. Whereas high school, so versus high school for elementary, math, English, history, social studies, you have a homeroom teacher, it's taught in one space. High school, not the case. You have a dedicated teacher or two now, and different buildings are different spaces to serve those needs. So as the program becomes more difficult, we want to shift to the space by space method for education. So other options. So if you don't have a working room schedule in Revit, or you don't want to work in Excel, I recommend ComCheck Online. What? Why do I have difficulty logging into that? Not signed in. So ComCheck Online. Yeah, but basically this is a really, really helpful tool. It can be used for other aspects, but for lighting, it's very helpful. So you come over here, select what code. It also has a handful of local codes inside of it if there are different changes. So we're talking about 2018 IECC. And then Idaho. Easy. So whether it's new construction, addition, alterations, we're doing different compliant options. But basically, so we have building envelope area. So we want to come over to interior lighting, see the building area method and space by space method here. So you can start filling it out and doing that. I'll come back to that in a moment. So allowance versus budget. So basically we're talking about the specific amount of money we can spend, but instead of money, we're talking about watts. And that's important to keep track of our budget because the interior power is not allowed to be greater than our interior power allowance, okay? And also mention that because there's some things in our budget we can't keep track of that we're responsible for. So if someone adds additional task lighting or supplemental lighting to a space, they don't tell us, we're still responsible for that, okay? So we definitely do need to keep track of it. So for the space by space method, just doing quick rough estimations for determining our lighting layout. This is what you need for the space layout. Ceiling height, work plane height, area, are we doing a grid or no grid? What is the lighting type? Linear, recessed, track, dropper, exposed. Can not just be one, it could be multiple different types of lighting. And then foot candle, determine the appropriate illumination levels. So refer to IES, the Illuminating Engineering Society, or better yet, directly from the manufacturer that they give you with the product purchase. Yes. So lumen is the efficiency. So luminous efficacy. So it's our rate of measuring the efficiency of that light, whereas lux or foot candle is the quality, so to speak, of that. And so for our example, sticking with a standard classroom in our high school, ceiling height of 8 feet, work plane height 30 inches. This 1,240 square feet, that is an average high school classroom size in America. Okay. And keep in mind, not all classroom sizes are going to be the same size. Some of them are going to be different. So in this example, it's pretty easy for me because I'm saying all my classrooms are the same size. Lighting type, we're going with a troffer, and then foot candle recommendation is 35 or 50 foot candles. If you need lux, multiply by 10.764. I will tell you, if you look at a lot of the tables and you see, the 300 lux and then 25 foot candles, that's not a 1-to-1. That's not, using the exact multiplier, but it's close enough. Okay. And generally speaking, we don't use lux in America. So we want to estimate our budget per classroom. So here I'm applying different, using standard layout that I decided. It's going to be 27.5 feet by 45 feet. We have our fixture type in our grid. We know our foot candle level. So it's just determining the layout. So looking at different number of fixtures by the average watt for a 2x4 troffer, we're going to see is somewhere 28 to 35, but I want to give myself more of a budget down the, or cushion down the road. So I'm using 35 watts. So we get our watts per classroom and then our LPD per classroom. It's showing up. And then we have our IECC requirement of 0.96. So again, we're not going to have 24 fixtures in our classroom, right? That's just not realistic, but that's the max we can have at that wattage to meet the LPD and not go over it. So that's our ceiling. So we know that where that is. Oh, sorry, I changed slides on you. So this one is 1240. So 34 fixtures would be the max ceiling, but say our classroom is a little bit smaller. We change it to 875 square feet. So then that changes our LPD per classroom based off of the number of fixtures we have. So in this example where we drop the square footage, now we can only have 24, whereas before we had 34. Okay, so it's important to keep track of that. So let's review. So for building area method, we have 129,600 watts allowed. Then we have 2x4 recessed troffer LED, 15 fixtures is what I'm choosing. Reality, I can probably get away with 9. I would probably compromise with 12. But for the example, like I said, I want to give myself a cushion down the road. So we're doing 15 fixtures. So that gives us 525 watts per classroom. Let's say we have 53 classrooms in this high school, our standard classrooms, not specialty. So that would give us 27,825 watts that we're spending based off of the fixtures we've selected. So that would be 21.46 of our budget being allocated. Okay. Now, if we do the space by space method, we have 0.96 LPD, taking that area, that gives us 1,190.4 watts permitted. That's our budget. What we're actually spending, though, is 59,520 watts. So we take that, that's our watts permitted for the 50 classrooms. And then I just realized I changed that. I don't know why I changed that to 50 classrooms, I'm sorry. But basically we take that 59,520 watts that are budgeted, and then we're spending 27,825 watts. So we get 31,695 tradable watts because we're using the space by space method. So what that means is, say in an actual building, the classrooms wouldn't be the same. Some would be bigger, some would be smaller. If we're overspending in classroom A, but we're underspending in classroom B, we can take that excess in classroom B and say we're using it in classroom A. Okay, but you need to show your work. Okay, and show exactly how you got all your tradable watts and where they're going and where they're being rehomed. Does that make sense?
We trade those to another space beside the classroom.
Yep, it is not stated in the code that it has to be space type to space type. I disagree with that. I think it should. I think it should have some correlation. But say you have a larger gymnasium, you're getting really high efficiency or high wattage fixtures because they're high bay, and you're spending over what you're allowed. In your classrooms, if you're saving 5% in each classrooms, you have 50 classrooms, that adds up, and you can say, hey, we're gonna take all that excess tradable watts that we're not using in our classrooms, and we're gonna say, hey, we're spending it in the gymnasium. That is allowed. And so basically, because again, you want to keep track of it, I broke it down. So it'd be 665.4 watts tradable per classroom. So you would know, okay, each classroom will take this. So if we need 1200 watts, but okay, we're taking all of classroom A and we're taking 95% of classroom B, and you show that work. So, and again, you don't get to trade off or get exemptions unless it's explicitly stated in the code. So, continuing that, here's an example using the gymnasium or fitness center. So we have 0.5 LPD for the playing area. Again, because this is not the performance where we're hosting games, this is PE, like dodgeball, volleyball, basketball, all that stuff here. So based off this layout, 87.5 feet by 100 feet, we're getting 8,700 square feet. Or sorry, 8,750 square feet, which means we're permitted to have 4,325 watts. So let's just say we have LED high bay fixtures. We have 42 of them at 85 watts. So that gives us 3,570 watts. By that, we get a 0.41 LPD. We're in compliance. And again, as I said earlier, you don't want to min max. Okay, so you don't want to say, hey, okay, we have this much we can spend. We have to spend all of it. No, 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 no. Give yourself some breather. 5 to 10%, I would say, is probably pretty good. So here we have 755 tradable watts. And again, I just want to point out this isn't a vacuum. There would not actually be 42 fixtures because I didn't, in my layout, I didn't take into consideration HVAC, any additional equipment, any structure, or any skylights being laid out. So it would definitely be, you would not have 42 fixtures in this space. Okay. That is just in a vacuum on paper. Give you an example. So do these projections for each space, regardless of the method being applied, because again, it's going to help you and save you time throughout the design process. So with the workflow, you'll just have to update the values as information becomes available to you. And so it just gets more refined and more accurate as you go. So as I mentioned earlier, this work has to be done. So if you want to do it all at once, that's your prerogative, but I would recommend doing it a little bit over time. So here is something you can do for a quick estimation. This is not a product endorsement. This happens to be the first lighting manufacturer I clicked on for my Google search. And so I will say a lot of the lighting manufacturers have a tool like this available. So you come down here, indoor, yes, yes, yes. Okay, I'm sure it's all right. So we got an indoor calculator. I'm gonna open this guy up. And so this is kind of a quick and easy way of doing a lighting layout and determining it. So you come over here and this is, so we say IES, that's the file type from Illuminating Engineering Society that basically has all the digital information about how the light performs. And so you basically scroll through the catalog. Basically what I would recommend is using the lighting manufacturer's brand. You can look at the picture, but you can basically be like, I need a troffer, this is your brand, pull up the first one, look up the series, so it'll be CHB, and so then you could scroll down and find that immediately. Let's just say we're doing this guy. So we have our luminaire selected. You can look at the description, so if we want to override it based off of the product catalog selection, because you can get different wattage and voltage and requirements. And this is pretty much generic. A lot of the manufacturers have this a very similar user interface, so it's pretty applicable. You can change the shape of the luminaire. Right now it's 2 by 2 by 1.7, so that actually doesn't work for what I specified. So I'd have to go select another one, change the geometry, work plane height, suspension height, everything like that. And then you can say, what's your desired illuminance? It's 40, so it will automatically rearrange and add fixtures based off of its math from using the luminaire IES file for you. Okay, you're still required to do due diligence and do your own calculations, but this is good for early estimation. And then you come out here, you can change the units, the theme of how it looks. And you can change the layout, put your 3x1, different spacing, grid, things like that. Again, not a product endorsement. Multiple lighting manufacturers have that. Not endorsing Econolight. So, any questions on allowance? Anything so far? Okay. So, total connected interior lighting power. So this is the value that has to be lower than our allowance, okay? And this is how you calculate it. There's 4 different categories, and you have to figure out where your power fits into which bucket. So LVL for luminaires with lamps connected directly to building power, such as line voltage lamps, LVL. For BLL for luminaires incorporating a ballast or transformers, i.e. fluorescent lighting. Is typical, and then LED is its own category, so it's an LED, put in the LED. And then track lighting, for lighting track, cable conductor, rail conductor, and plug-in busway systems, you have a couple options. So the specified wattage of luminaire, but not less than 8 watts per linear foot, or 25 watts per linear meter. The wattage limit of the permanent current limiting device protecting the system. The wattage limit of transformers supplying the system, and then you have other. So if it doesn't fit into one of those first 3 categories, it goes into the other. Now, there are a lot of exemptions that you can apply because it says the. Sorry. So the exemptions you can apply, because it's basically anything that kind of gives off light into the space needs to be considered, but there are quite a bit of exemptions. So anything outlined here is not. So television broadcast lighting for playing areas, emergency lighting, automatically off during normal building operations, lighting in spaces designed for use by occupants with special needs. That has its own call out several times in the lighting code, so it has its own section. Casino gaming areas or mirror lighting in dressing rooms. So, it's pretty straightforward. Common sense applies. What an exception would be. Task lighting for medical dental purposes, display lighting for galleries, museums, monuments, in addition to general lighting controlled by an independent control device. Theatrical purposes, perform, stage, film production, photography, again, pretty straightforward, common sense application of the code. Lighting integral equipment or instrumentation installed by the manufacturer, as in it came with the equipment, so you don't have a choice. Task lighting for plant growth or maintenance, advertising signage or directional signage, lighting for food warming, lighting equipment that is for sale. So anything you see at like Home Depot or Lowe's where they have all the lights and chandeliers up, that's not being counted. Lighting demonstration equipment in lighting educational facilities. So this is in educational facilities. Those 4 lights I use as part of my their luminaire level lighting controls. They have embedded sensors in them. If we were doing a retrofit, I could get this space as well as the office space out there exempt because it's an educational lighting equipment. Lighting approved because of safety considerations, i.e. mostly circulation. Lighting in retail display windows, provided that the display area is enclosed by the ceiling height partitions. Furniture mounted supplemental task lighting that is controlled by automatic shutoff and exit signs. So calculate the total ILP first and then apply your exemptions and your trade-offs, okay? Because again, you want to show your work, especially if you're doing trade-offs and exemptions. You have to be able to show where everything went. Also, don't forget parking. Something that's, I think, kind of gets overlooked is if it's covered or enclosed parking garages, included in open parking garages are included in the requirements for interior lighting. So if you have a 3-story parking garage, first one's covered, second floor is covered, third floor is not. First 2 floors are included in interior lighting power. Third floor is exterior. Little tricky. So just to remind you, lamps work by converting electricity, gas, or solar energy into visible light, each type utilizing a different mechanism for this conversion. So it's kind of like helpful graphic to kind of see how all the categories fit, but they all get put into a bucket for interior lighting power and allowance. So, quick, sorry, I gotta get my password. Because I have, so an example I want to show you for the retail exemptions. This is a Costco. I chose them because they can take pretty much almost all the exemptions they can apply for. So additional lighting power. So not so much an exemption, but extra allowance. So you get 1,000 watts, plus you get 4 different categories, retail area 1 through 4, and they're each applied at a different watts per square foot. So retail 1 is everything that doesn't fit in 2, 3, or 4. Retail 2 is the floor area used for the sale of vehicles, sporting goods, and small electronics. Retail 3 is the sale of furniture, clothing, cosmetics, and artwork. Retail 4 is used for the sale of jewelry, crystal, and china. Okay. So using the example of Costco and estimating kind of the area for that, this is what I came up with. So they have the ability to take advantage of all 3. So if we go back and look at it, we have electronics. I know there's jewelry there, there's health and beauty, there's clothing. I know they sell artwork as well. Then you have general sale, retail sale that would encapsulate everything else. So that would give us 44,740 additional interior lighting power. But before you get too excited, there are requirements to it. So for spaces in which lighting is specified to be installed in addition to general lighting for the purpose of decorative appearance or for highlighting arts or exhibits, provided that the additional lighting power shall not be more than 0.9 watts per square foot in lobbies and not more than 0.75 square foot in everywhere else. But the main thing to be concerned about is the additional power shall not be used for any other purpose. Okay, you don't just get to start adding additional fixtures and additional layering of light. It has to be very specific and shall only be permitted where the specified lighting is installed and automatically controlled separately from the general lighting to be turned off non-business hours. Okay, and you can only get this extra retail additional lighting power if you're using the space by space method. Okay. So before I shift to exterior lighting. Sorry. Okay. So I highly recommend you make an account because you can save different projects. So let's run through a couple. So here are examples you'll find in the expanded code commentary. So you can just basically set it all up, loading area types. So using building area method, so you don't have anything to fill out here. So if we come up here to interior lighting, you can see I've already started to fill some of these out. So you can come in here and make sure you're clicked on different program area before you add a lighting type to it. But see, you can get a little specific if you want, or depending on how you want to set it up, because I like to just keep track of where all the lights are. Because you can also take this and download it as a CXL, so you can bring it to Excel, and if you want to start here and then go to Excel, that works as well. But keeping track of it, number of fixtures, different wattages, you don't have to stick with what's given to you. You can come here and change it, and then it will update down the line. So you can see here, we have our allowed wattage and our proposed wattage. So yeah, it doesn't like that I didn't have any fixtures here, but you see locker room, reception, fitness area. So this is, even though this is the building area method, I've broken it down space by space, so I can detail out how much wattage I'm spending per space, because I know the lighting layout and the fixture selections. So, and then you can come in and fill it out. Space by space. So here you see a interior lighting method. I got the area category space by space. So this opens up. So if we wanted to add an area category, this is what happens. So this is basically the table digitized from the code book. So for us, retail, dressing, fitting room, mall concourse, sales area. So they have all that. If you want to color outside the line, you can go to common space types and just call it sales area, because it doesn't necessarily fit into retail, but it's close. And so you come in here, you fill it out, the area. I didn't do the ceiling height, but it'll give you your LPD requirement associated with that space type. And move over to interior lighting. And so we see all that allowed wattage, our proposed wattage. We can start adding fixtures to it. But so better example I have is using this Costco in here.
Customer tell you what lighting fixtures they buy, and we recommend them specifically.
So I'm typically my role as a consultant. So I advise. I'm not really allowed to say go buy this one. So typically, what I do is I'll outline the requirements that the fixture needs to have, their luminous efficacy, foot candle rating, what the ceiling height is going to be, the typical layout, based off this the space type, and then package that up, give it to them. They take it to a lighting rep, and the lighting rep says, "Oh, okay, well, in my catalog fixture, all these fixtures fit those needs. Which one would you like?" And then that typically moves into interior designer, and aesthetics, and additional things like that.
And then,
But then that comes back again when you need to have the control strategies applied. So then that might override, because like, oh, this one looks better, but we have to do this control strategy based off of code requirements. So no, you don't get that one. We get this one.
so what, from an enforcement perspective, are the plan reviewers and stuff up on this, or are you basically they taking your word and everything? Does a com check do all of that for you? It says this meets the law as I'm submitting.
Yes. So you have the check compliance down here. So there's an option. So it'll tell you, so like interior lighting. Right now I'm passing because I've only filled out one area. So I'm way under my power is way under my allowance. So they're like, of course you're passing.
Typically, ours during the file review just accepts that bill.
I would recommend double checking it. Because again, this is a layer removed from code. So you always want to double check the math, or at least have someone, double check your work. So, because ComCheck can be wrong. It can do the math incorrectly, or you may want to apply a specific exemption. So like getting into, so like here's the requirements tab over here. So now that I've run it, it shows it down there, but it shows you previous one up here, so the entire project level, but we're concerned about interior lighting. So now it goes through all this, like here's the control section. So it's letting you know based off of your space types that you input in the area, it's taking that into consideration from the code requirements to say, okay, you're gonna need occupancy sensors in classrooms because it's classroom lecture training, things like that. In addition to wattage, so here's the interior lighting power allowed for specific functions. And then here's exit signs do not exceed 5 watts per phase, things like that. But for the Costco example, so we got a retail one. So we have sales area, they're all sales area, but when I went to the project in here, I went to the area description. I said, okay, this is going to be my retail 2, this is going to be my retail 3. And that's how I'm going to be able to track it in the program as it's calculated. And so now I know where to apply those exemptions based off of my proposed and allowed wattage. Okay. So kind of run through exterior lighting power allowance. It's basically the same thing as interior, but we're doing it on exterior. And in my opinion, it's a lot easier because you have 2 tables and you follow the 2 tables. That's it. That's all you got to do. So with the 2 questions is you have to ask yourself is what zones are applicable to your site and what is the program of each zone. So these are the zones I'm talking about. This is the first table. So lighting zone 1 is developed areas of national parks, state parks, forest lands, and rural areas. Lighting zone 2 areas predominantly consisting of residential zoning, neighborhood district, business districts, light industrial with limited nighttime use, and residential mixed use areas. So i.e. refer to the zoning code of the city that you're building. Lighting zone 3 is all other ones not in 1, 2, or 4. 4 is a high activity commercial district in major metropolitan area as designated by the local land use planning authority. So again, for determining this, look at the zoning code. That will tell you what zone you're in. And the important thing to note is that the lighting zone for building exterior is determined in accordance with this table unless otherwise specified by the code official. Okay. So what is the program of each zone? So basically you basically go down the first hand column and then you go over to your applicable zone, and that's going to get you your limits. So you have a base site allowance depending on which zone you fall into, and then it's broken into parking areas and drives, walkways. So here's what the walkways with a ramp less than 10 feet wide, and then those for 10 feet wide or greater. And then exterior dining areas, exterior stairways, pedestrian tunnels, landscaping. Each of them have watts per square footage associated. So making sure you know the boundaries of your zone is important because that gives you your area. You are allowed to have more than 1 zone on a site if it's applicable. Okay, and you will have to call that out and say this is the boundary for zone 2 and this is the boundary for zone 3. So uncovered parking areas, building grounds, and then building entrances and exits. Regarding pedestrian and vehicle entrances and exits, entry canopies, loading docks, and then specifically sales canopy. So lighting has a unique relationship with retail. We like things shiny, bright. Ooh, I want to buy that. Ooh, it looks great in that light. Ooh, this looks nice. So we tend to give a lot of exemptions to them. In addition to if they're doing daylighting, in addition to their retail display. So just keep that in mind. Open areas, including vehicle sales for lots. So anything outdoor sales. And then street frontage for those, building facades, ATMs, uncovered entrances and gatehouse. So it's pretty straightforward. You just look at the table. This applies to me. I'm in this zone. Okay, this is my limit. And then you basically, just like the interior lighting power allowance, you're adding all those up, and that's what you get. This gets complicated when you get into ASHRAE 90.1, regardless of the version, because they give you they go with building surface area for the facade, and you can trade watts depending on the facade location and other requirements. So this is definitely a much more simpler version of that. There are exemptions for this one too, for calculating the exterior lighting power. Lighting approved because of safety concerns, emergency lighting automatically off during normal business operations, exit signs, specialized signage, directional markers, advertising signage, integral to equipment or instrumentation and installed by the manufacturer. Theatrical performances, including performance stage, film and videos, athletic playing areas, temporary lighting, industrial production, material handling, transportation sites, and associated storage areas, theme elements, and theme and amusement parks, kind of anything that's used for the commercial application is, that is essential for that sale or activity to take place. We kind of not knocking people for having lighting for that, because that's the whole reason why that space or entertainment value or something exists. In addition, so like if you have public parks or artwork, or statues or monuments, as well as the national flag, we're not counting that against you. This one I really don't like is the lighting for water features and swimming pools. I don't know why that's exempt, but it is. Lighting controls from within dwelling units where a listing complies with section R404.1, i.e. that's a multifamily reference. But that's pretty much it for the exterior lighting power. You really shouldn't have any problem staying under you're getting your power under your allowance. The exemptions are pretty generous, as well as your general allowance is pretty generous. So you really shouldn't have a problem unless you're going with a more stricter code requirement like 90.1. Any questions on exterior building? Okay. So to wrap up, one last thing I want to make you aware of, there's an additional section, C406.1. You're probably going to hear about that from your mechanical engineer because they're going for efficiency requirements. So there's two options you can do in that. One of them is about power, the other one's about lighting controls. So this is the lighting power one. So keeping with our same example, using the building area method, you have to have a 10% reduction. So it has to be, the way it's worded in the code book is that your interior lighting power should not be, your interior lighting power allowance should not be greater than 90% of what you calculated, i.e. take a 10% haircut. So instead of having 129,600 watts, we would self-impose a limit of 116,640 watts. Okay. The other way to do that is applying that 10% reduction is you take 90% of the LPD. So instead of it, so now our LPD is 0.864 that we're applying to our classrooms. We go through the math and do all that. Now our tradable watts is 25,743. Okay, so still quite a bit. If you are doing the efficiency package options, make sure you're doing the space by space method. That will ensure you have enough allowance for your wattage with your cushion and then the efficiency as well. So the space by space method, in my opinion, just gives you extra cushion for the efficiency option and any unintended power that will be added to the spaces when it's being built or commissioned, etc. And that's what I got for you.